Okay, so welcome back to Lehigh Tutoring. In the last video, we did um, limit evaluation by direct substitution, and I even touched upon situations where you can't do direct substitution. So the situation or the example that I did was the following. It was the limit. Let me just fix the page here. It was part A of number 4, right? So I had this situation. I had A limit as x approaches -2 of x squared minus 4 all over x plus 2. This guy could be factored because it's a difference of squares, so I got x minus 2, x plus 2 all over x plus 2. And then that left me with a cancellation, right? Now I'm missing the limit as x approaches -2, that part, but I'm just going to rewrite it here. Always make sure it's there, right? -2, and I've got x minus 2. Now x minus 2 is a polynomial of degree 1. So in cases like this, I literally just have to plug in -2, right? And we talked about that in the last video, and by the way, I'll leave a link to the last video in the description. So we get -2 minus 2, right? And so we get -4 as our answer. That was the answer we had before. So we kind of touched upon this, and this specific method actually of evaluating limits that are not direct substitution. This exact method is called factoring, right? So you factor something, right? Either the numerator or the denominator. You can cancel out a factor that really hurts you, right, in evaluating the limit by direct substitution, and then you pull direct substitution, and then you get your answer. So so in these cases, right, from A to F, we've got like a whole lot of situations where you can do where you can do factoring, right? So I did A, right? So let's do B together. Why don't we do that? In fact, I can just do a new page, right? Discard. Oops. Okay. Oops. I think I made a mistake here. Let me go back. Okay. Close it. Right click. Open with Zernal. So I won't do that again. And then we're going to full screen it. Okay. Actually, I should zoom in first. Zoom. Control plus plus. Okay, let's try this again. I guess I'll just erase things manually. Okay, so we did part A. So now we're going to do part B. Okay, so we've got limit. Thanks for sticking with me. We got limit as x approaches 1 of x squared plus x minus 2 all over x minus 1. Now, if this is a factoring method, chances are there's going to be a factor of x minus 1 inside this guy, inside the top, right? Thus, you can cancel, and then so you're going to get a factor of x minus 1 sticking out of both, so you could just kill them, right? So, and then I could just do direct substitution on whatever's left. So I got to pull out a factor of x minus 1 in the top. So let's do that. So x approaches 1. So if I've got an x minus 1 factor in the top, I need to figure out what I put here so that I can produce this quadratic if I do FOIL, right, backwards. So I'm going to put x plus 2. Now let's quickly check. So I got x squared minus x plus 2x. That gives me a plus x. That's looking good. And then -1 times 2, -2. So these are our two factors. Okay? And we've got x minus 1 in the bottom. So again, we cancel, right? And now I've got limit as x approaches 1 of x plus 2. And again, this is a polynomial, okay, of degree 1 in this case. So now I can just plug in x approaches 1. I plug in x equal 1. And so I get 1 plus 2, and I get 3 as my answer. Okay, so that's that question. So once you do this, enough, you get the hang of it, and it actually becomes really, really straightforward. It's not too bad. And I'm hoping that you all make sense of it, and yeah, it becomes second nature to you. So yeah, so we've got part C. Let's see, what do we have for part C? This is a little different, obviously, but again, so you got a cube, right, in the top, degree 3. You got difference of squares. So the top, will look like a difference of cubes. And the reason why I say that is because 2 cubed is 8, right? So I can rewrite this as x cubed minus 2 cubed, okay, all over x squared minus 4. And again, x squared minus 4 is a difference of squares. So I'm going to rewrite this as 2 squared just to drive the point home. So there are a couple of formulas that I can use here. So x cubed, okay, minus, some y cubed equals x minus y, okay, times x squared minus xy plus y squared. Okay, this is a rule that we can use, right? So if I do the expansion back, I should get x cubed minus y cubed. Moreover, difference of squares we know, right, will be x minus y and x plus y. Okay, so why don't we apply these? Okay, so to the top, instead of putting y, I put 2. So the first factor, let me write limit as x approaches 2. Okay, the first factor is going to be x minus 2, right? The second factor, right, as part of the difference of cubes, will be x squared minus 2x, and I want you guys to check, right, just so we're all on the same page, and then it's plus 2 squared, which is 4. Okay, so go back and check the math, and you should find that everything works out. Then we got x minus 2 and x plus 2, okay? Right. So, I think this should actually be a plus if I'm not mistaken. I think that should be a plus. Let's try doing the expansion just to make sure. So we've got x cubed, right, plus xy, x squared y, plus xy squared, okay, minus x squared y. This is looking good. Minus xy squared minus y cubed. Yep, this is looking real good. Yeah, so it's actually this factor, I apologize. So this is the rule. So I changed it in the top, and now I can kill these two terms. And now there should be no problem by just evaluating by substituting 2 in, right? So I do that, 2 squared, okay, plus 2 times 2, which is also 2 squared, plus 4, okay, all over 2 plus 2, which is 4. Very funny. So this is 4 plus 4 plus 4. Okay, so 4 times 3, that's 12. All over 4, we got 3. Okay, again, if I make any mistake, please leave a comment, let me know so I can make a note about it, and in the next video I can, talk about it and clear the air. Okay, so we've got this situation. All right, and I'm just going to erase the top here, as we might need these guys in the bottom later, right? So I'm going to kill this. Apologize for the erasing, right? It's taken a bit of time off of the video. Yeah, I also just want to say, if you guys have, any sort of worksheet that you actually want to have me answer in a video on YouTube, I will do it, no problem. Just send the entire worksheet either via PDF or just take a picture of it, honestly, as long as it's viewable, and send it to contact, right? Contact, where am I going to write it? Contact at lehightutoring.com, okay? And we will actually be able to answer any questions you have, and it'll be great, and we'll have direct contact with you. That's perfect. So next question is D, right? So we did C, now it's D. So it's limit as x approaches 3 of x squared minus 2x minus 3, x squared minus 4x plus 3. Now notice, there's a pattern with these factoring questions. Two factors have to come out of each and cancel each other, and it's probably going to be the factor that has 3 as its quote-unquote 0, right? So if you plug in 3, you get 0. Now the only factor where that works is x minus 3, right? So probably an x minus 3 is going to stick out like a sore thumb out of both the top and the bottom. Okay, now we just need to figure out what the other factors are to make these nice quadratic standard form quadratics, and then we're good. So in this case, we need a number that multiplies to negative 3. Well, the only case is positive 1. And that works perfectly because the middle term will be negative 2x, and I want you guys to double check that, okay? Here, you've got a positive 3, right? And you've got a negative 3 written here, so this has to be minus 1, okay? And that will also produce a, a middle term of negative 4x, okay? So we're good. So now these guys cancel as before, right? And now there's no problem with just plugging in 3. So I'm going to do that. So 3 plus 1 all over 3 minus 1. So we got 4 over 2, and we got 2. Nice. Okay, so next we're going to do part E. And now instead of a difference of cubes, right, notice the top, right, says x cubed plus 27. Well, I can rewrite 27 as 3 cubed, right? Oops, that looks like 33. 3 cubed. Make sure when you're writing stuff on your tests that there is no ambiguity, right? You want to make sure that when it says 3 cubed, it says 3 cubed. It doesn't say 33. We don't want you losing marks for no reason, right? So that's our situation. And now the limit x approaches negative 3. So let's write that down, negative 3. Okay, so x cubed plus 27. I'm going to go ahead and write it as 3 cubed. I hope that's okay. And x plus 3. Okay, now the only difference, right, is that x cubed plus y cubed, the only difference between these two guys is a flip of signs, right? So x plus y, and that's x squared minus xy plus y squared, excuse me. Okay, so this sign changes and this sign changes. Okay, there needs to be a change of sign twice. So I can do this. So I go limit as x approaches negative 3, x plus 3, okay? This becomes x squared minus 3x. And again, make sure you double check this, right, using my little rule. Oops. I'm still getting used to this, this tablet. And I still get x plus 3 in the bottom, okay? These guys cancel, very nice. And again, I can plug in negative 3 into the remaining polynomial of degree 2. So I get the square of negative 3, which is just 9, right? And then in essence, this is also negative 3 times negative 3, so I get 9 again, plus 9 at the end, and I get 27 as my answer. So that's the answer to question E. Please do not be confused. I apologize. That is question E. Okay, so we did a sum of cubes, a difference of cubes. Now we've got this funny situation where you can do a fraction within a fraction. Now when you have a situation like this, right, 9 times out of 10, again, what you'll have to do is you'll have to pull out a factor of x minus 2 in the top to kill this guy, right, so that there is no problem with the evaluation of the limit. But in this case, all you have to do is produce a common denominator in the bottom. And 9 times out of 10 is just 2 times x. It's just the product of the two. So let's do that right now. And again, I'll leave these rules for you. Okay, so f, right, limit as x approaches 2 of 1 over x, okay, minus 1 over 2, all over x minus 2. So let's do a common denominator in the very top, okay? So limit as x approaches 2. I'll leave this monstrosity at the bottom, and I'll do 2x. So that's a common denominator. Now, it's very easy to put these together. So all I have to do is, in the common denominator, note that the two factors together are 2x. Here I only have x. So what's missing from the top and the bottom is 2. So the first term will have a 2. Then I subtract, and now this term is missing an x, so I end up getting this, 2 minus x. Now why that's neat is that 2 minus x equals negative of x minus 2. So if I so choose to cross these guys out, no problem, so long as I put a negative 1. That's the only condition, right? So I got limit as x approaches 2 of negative 1 over 2x. Now notice there is absolutely no problem with just plugging in 2, okay? So I do that. So I get negative 1 over 2 times 2, and I get negative 1 over 4, done deal, okay? So that is factoring, okay? Now I'm going to have to basically erase all of this extra stuff at the bottom in order to move forward with another method for solving limits. So we just did 6 examples, okay, 6 examples of factoring, right, which are fun. I like factoring problems. What's even more fun, though, in my opinion, is conjugation, right, the conjugate method. So the conjugate method involves rational, when you have functions that are quotients, right, and you have square roots inside, right. So if you notice on the right side, right, you've got a bunch of square roots, okay. What you have to do is you have to multiply the top and the bottom by conjugates, okay. So why don't we do this? Let me move it. Let's do all of 5, and let's try to do all of 6. Are you hanging in there with me? So let's do part A. Okay, so the limit, I'm going to try to write small enough so that so I can fit more examples onto here. So x minus 4, okay, root of x minus 2. Now, the conjugate is essentially you take the guy that has the square root, right, and you just put a plus. So what I'm going to do is I'm going to multiply by that conjugate, okay? So the conjugate is root of x plus 2, root of x plus 2. Now here, if you work out the FOIL, right, you will always get a difference of squares, just like we did before, right? But a difference of squares in this case, the product of it will just be x minus 4. Okay, work that out. You will see it. It's going to be the square of root x minus the square of 2, and that just happens to be x minus 4. Now, obviously, it better be x minus 4, right? Because we want to cancel x minus 4 because that's where we get problems, right? So we want to remove that. That's our cancer. We don't want that. So in the end, we get the root of x plus 2. Okay, and then we do our limit. Again, I forgot it. That is bad, by the way. Never forget it. And I can literally just plug in 4. So I get the square root of 4, which is 2. 2 plus 2, that's 4, and we're done. We're off and running. So part B, okay, is a same situation, okay, limit as x approaches 1, root of x minus x, okay. You look at the one that has the square root, right? And then you multiply by the conjugate. So, so here we go. Root of x plus x, root of x plus x. These two guys will make, at the very top, you will get x minus x squared. And then we got x minus 1, root of x plus x. Now, do not panic, okay? So this doesn't look like we've solved anything just yet, but when there's a will, there's a way. So all we have to do is factor out x out of the top, okay? So why don't we do that? And we've got 1 minus x. Aha! There we go. Now we're talking. X minus 1 has to go away. And this is the same situation as before. If we cancel this and this, right, they're opposites, we gotta put a minus sign. Have to. So in the end, what we end up having is a limit as x approaches 1 of negative x over root x plus x. We've got absolutely no problem of plugging in 1 now. So we do it. Negative 1 over root of 1, which is 1, plus 1 equals negative 1/2. And we're good. We're golden. Okay? So we just did part B, and now we're going to do a slightly harder question on conjugation method, because you've got, a more complicated square root, if you will. It's not just root x, it's a root of 6 minus x, although it's not too bad, and you will see that in a moment. So yeah, I love doing this stuff. I love tutoring and helping people. When I was a youngster, I didn't have anyone to help me, and I had to do this on my own. And I had suffered a lot because I wasn't the smartest, brightest bulb in the box. But yeah, so things are okay now. So happy with the results. So let's do this. So we've got 6 minus x plus 2. Okay, the root of 6 minus x plus 2. Okay, so I multiply by the conjugate of that. We've got square roots in both. Notice that. Okay, so in the top now, I will get, this is maddening, so I'll get 6 minus x, right? That's the square. Whoops. It's very easy to do that. I'm sorry, on this tablet. The square of root of 6 minus x is just 6 minus x. And so I get 6 minus x minus 4. Okay, now I will also multiply the top and the bottom by the conjugate of the guy on the bottom. So you have to use the conjugate method kind of twice, right? Now try not to get too confused, okay? Like, don't worry, take it one step at a time. This guy will hook up with this guy, and we end up getting 3 minus x, which is the square root of 3 minus x, minus 1, okay? So it's boom. Maybe that'll help, I'm not sure. But anyway, it's like a minus b times a plus b, and you get a squared minus b squared. It's that. So the factor that didn't eliminate, right, or get swallowed, was this one on the bottom, okay, and this guy on the top. So we got to rewrite those in, okay. So we get that, and we just got to simplify, that's all it takes. Just got to simplify. So 6 minus 4, let's do this. 6 minus 4, that's 2. Minus x, 2 minus x. Great. Here, I've got 3 minus x minus 1. So I can group 3 minus 1, right, and get 2, so 2 minus x again. And notice that is the factor that's giving us issues with this limit, that if I were to do away with it, we'd be fine. We'd be happy, right? And we could just do direct substitution. So I get rid of it, right? So I cancel everything, and now I can literally just plug in 2. So 3 minus 2 is 1. The square root of 1 is 1. Plus 1, that's 2, over. Plug in 2 again. 6 minus 4, 6 minus 2 is 4. Square root of 4 is 2. 2 plus 2 is 4. And I get a final result of a half. Okay? So that's that. Literally no problem. This involved double conjugation, so I guess you could use that as a bit of a rule of thumb. The number of square roots you see, if you see a square root on the top, a square root on the bottom, probably have to do 2 conjugates, right? And then once you do that, using a squared minus b squared equals a minus b times a plus b, you can pretty much climb to your answer, no problem, okay? No problem. So we get that. Thanks for sticking with me. So we're almost done most of the conjugation, right? So not most of the conjugation, but we've gone a far bit into it. So here 3 plus t minus root 3, okay? Now, what do you think the conjugate's going to be in this case? That's right, it's going to be root of 3 plus t plus root of 3. Good. So literally, you know what, I'm just going to write it in. It's probably better. Okay, so root of 3 plus t plus root of 3, okay, over root of 3 plus t plus root of 3. Notice that I'm putting a factor on the top and the bottom, by the way. You want to do this because if you just put the top or just the bottom, you've now changed the problem. We don't want to do that. We want to solve this limit, right? This limit right here. We want to solve that guy. So we multiply by essentially 1 and just make it look nicer. Okay, so we've got limit as t approaches 0. Okay, now the top should produce, okay, 3 plus t minus 3. Okay, the reason why is because the square of root of 3 plus t is 3 plus t, and the square of root of 3 is 3. Okay, so if I'm losing you, or if you're about to barf because, you know, this is too much information to take in, take a deep breath and write it out. Okay, and so we get this, and 3 minus 3 is 0, so I can cancel those, and I'm left with just t in the top. So I hope you notice that. So that's the part that's giving us issues. So we can kill that off, okay, and if we do that, we have to leave a 1 at the top. So in the end, I get limit as t approaches 0, okay, of 1 over square root of 3 plus t plus root of 3. And then I can easily just plug in 0. No problem at all. So in the end, I will get 1 over root 3 plus root 3, okay? And that's 2 root 3. Now, what I'm going to do is I'm going to multiply the top and the bottom by root 3 to make it look nicer. Most answers usually don't have a square root in the bottom, from what I've noticed, okay? And so I'm going to get root 3 over 2, and root 3 times root 3 gives me just 3, right? So it's going to be root 3 over 6. That's how I would write it. We're good? Following me? Okay, so don't get lost. Okay, be happy. And next we're going to try to finish up conjugation. Okay, so I'm going to try to do these last two problems all at once so that we can get into number 6. Okay, so let's do this. Hopefully, you know, you're not barfing by now. I know I'm not. I'm actually excited. I love life. So root x, 1 over root x minus 1, all over x minus 1. Okay. Now, so there was one problem where we had, you know, fractions within fractions, f, 4f. So we need to do a common denominator again, okay, in this problem. I'm losing you. We have to do a common denominator again. Now, 1 can be written as anything over itself, right? Because 5 over 5 is 1, 6 over 6 is 1, 7 over 7 is 1, and guess what? Root of x over root of x is 1 as well, right? So we're going to do that before we do any conjugation at all. You'll see why. So, so I can rewrite this as 1 over root x, 1 minus root x all over root x. And I hope you know, if you divide the root x back into each term on the bottom, you will get this monstrosity on the numerator. Okay, double check that. Okay, so we get limit as x approaches 1, okay, and we've got, I'm going to clean it up a bit, root x, x minus 1, okay, 1 minus root x. So I just brought the root x to the bottom. That's all I did. Now, the guy that has the square root technically is root x and 1 minus root x, but this is the only problem. This is the only part of the problem that requires conjugation, because usually you need two terms, right? So we're going to do 1 plus root x, 1 plus root x. Now these guys in the top, guess what? They're going to make 1 minus x. Okay, and we get root x, x minus 1. Okay, and then this factor in the bottom is still there, right? So I can't let go of it. I got to write it out. So 1 over 1 plus root x. Okay, and again, if I cancel these guys out, no problem, okay? But I got to put, that's right, a negative 1. Looks like I'll need to erase this before I proceed with the next problem. So I get negative 1 then over root x times 1 plus root x. Done deal. Okay, now all I have to do is plug in 1. No problem. All right, so we get negative 1 over root of 1 is 1, and then 1 plus the root of 1, which is 2. Okay, so negative 1 half. Man, it seems like half and quarters and these fraction answers are usually really popular, right? So yeah, this is what we end up getting for most conjugate questions. The last one looks a little scary, I'll admit. So let's have a look at it really quick. And by last one, I mean 5F. And then I'll try to finish all of 6, right? And then what we can do is we can move on into the next batch. Okay, so I'll probably do another video. So this will I will probably end at 6, and we can I can keep doing more videos after this. So this is basically evaluating limits by conjugation and factoring, right? So let's see, limit as t approaches 0 of 1 over t, root of 1 plus t, okay, minus 1 over t. Now here's the thing, that t in the bottom is what's giving us a headache, right? Why don't we try something? Why don't we do t, why don't we try factoring out 1 over t, okay? Root of 1 plus t minus 1, okay? And let's see, I might make a mistake, okay? This is live, I'm doing it as you're doing it. So this is 1 plus t, let's see, I'm going to put it all in a common denominator, root of 1 plus t. So it's this plus 1, okay? So let's hope I'm not making a mistake here. So if we work it out, if we divide root of 1 plus t back, we end up getting this guy, so that's good. 1 over t, oops, don't get confused, that's a division line. So that is, let me rewrite this then. It is 1 minus root of 1 plus t, so 1 minus root of 1 plus t, okay? So now the conjugate that sticks out to me like a sore thumb is 1 plus root of 1 plus t, right? So I'm going to multiply. Let's see what happens. Root of 1 plus t. 1 plus root of 1 plus t. Okay, let's do this. Again, if I make a mistake, yell, okay? And give me a comment, right? Nothing obscene, nothing vulgar, right? Just something nice. So we get 1 minus root of 1. Oh, no. Stop. Okay, now these two guys in the top, right? So this guy and this guy will end up making 1 minus 1 plus t. Okay, that's a difference of squares again. And here I will get square root of 1 plus t, and then factor of 1 plus the square root of 1 plus t. Okay. Now, why that's fantastic is you'll see you'll get a factor of t in the top, right? Okay, so I'm going to dip a little bit over here, and I'm going to work on the problem. So limit as t approaches 0, 1 over t. Notice what I get on the top. 1 minus 1 is 0, so the 1's are going to kill each other. But if I factor in the negative, I get minus t in the top. Great, so I can cancel the t's. Haha. Okay, let's see if that does anything for us. 1 plus t, I think it will. I think it'll save our butts. So we can cancel, and we get a negative 1 in the top. And so we end up getting negative 1 over the square root of, and I'll just go ahead and plug in 0, okay? So you're with me? So 1 plus 0, 1 plus square root of 1 plus 0, okay? And this is just going to be 2. This is going to be 1. Again, guess what? We get negative 1/2, I believe, okay? So that's it. So we get that beautiful answer, okay? So we get negative 1/2. Again, if I make a mistake, let me know. There's a lot of math. A lot of math to cover in a little bit. So that's number 5, okay? That is number 5. The way I recommend you do this is you find, you go to the actual PDF, and if you want, again, I'll post the PDF in the actual in the actual not comment section, the description of the video. And what I want you to do is actually go through these problems and then reference this afterwards. See if you actually get the same answer, or watch the video as you're doing it, right? So before I start the actual question, do it yourself. If you screw up or if you can't do it right, for some reason, look at the answer that I have, and follow along, and hopefully it's gonna start making sense, and once you get good at it, you get good at it, right? Okay, so I'm going to start the problems. Here's what I'm going to do. I'm going to start the problems up there so it gives me more real estate, right? So right here is where I'm going to start number 6. All right, so so I'm going to do number 6. So limit as x approaches 8, okay? And I am doing all of this on the fly, okay? So this is the cubed root of x, okay? Make sure you don't write that as 3 root x, okay? I've had some students do that. Don't do that. Make sure it is a cubed root, okay? Now, what I can do is I can split this guy, okay? I can rewrite that as a difference of cubes if I wanted to, okay? So the way I do that is I would go, how am I going to do this? I'm going to do it over here, okay? So follow me. So this is x minus 8. That is the cube, okay, of the cubed root of x, okay? Whoa, say that 5 times fast, right? So the cubed of the cubed root of x, that's x, okay? And now I can rewrite this as 2 cubed, okay? So I've got a difference of cubes. Now we know what that's supposed to look like. I probably erased it, so my bad, right? But the way it's going to look like in factored form, this is a rule, right? It's going to be a minus b, okay, times, oops, maybe I need more real estate for this. So the top can be rewritten, okay, let me actually do it here, that might make more sense. Limit as x approaches 8, okay, and this is going to be cubed root of x cubed minus 2 cubed. Hopefully you can buy that, right? And now I can just use my little rule. So that's what I'm going to do. So really the top, the numerator, is going to look like this. It's going to be the cubed root of x minus 2. Now that's good because we can cancel this guy, and that's the part that's giving us problems. And then the next bit is going to be the cubed root of x, and that term itself is squared. Okay, so it's going to be like, x squared plus, and it's going to be 2 cubed root of x plus 4. Now I want you to go back again. Please go back and check this, okay? And so I get a cubed root of x minus 2 again in the bottom, because that's the factor. This goes away, okay, and I end up getting this weird set of terms. Limit as x approaches 8 of the square of the cubed root of x plus 2 cubed root of x plus 4, okay, and in the end I can just plug in 8. So why don't I just do that? So the cubed root of 8, that's 2, right? Because 2 times 2 times 2 is 8. So the cubed root of 8 is 2. So 2 squared plus 2 times, again, the cubed root of 8, which is 2, plus 4. 4 plus 4 plus 4 is 12. Okay, so no more fractions. Okay, so hopefully I didn't lose you. So this was a little tough. This is, I had to change the top to a weird kind of difference of cubes. Use a formula that I know, okay? So this is the formula that I know. And then why don't I write it here? A cubed minus b cubed equals a minus b, a squared plus ab plus b squared, okay? I used that in the second line on the numerator, all right? And then that helped me cancel the term that gave me trouble. I evaluated by substituting 8, and I got my answer. Okay, so that's what I ended up doing. This is fun. I actually do love, communicating with you and helping you as much as I can. I think that's like a pleasure for me, and it's fun. And I hope that this is all a learning experience for you, and that you are, learning along with me. Because even after all these years, I'm still learning, right? So, okay. So let's see. That was A. Let's do B. So B, limit as x approaches 4, okay, x to the 3 over 2 minus 8, and then x minus 4 on the bottom. Okay, this one isn't as obvious as before. Now, if I plug in x equals 4, I will get 4 to the 3 over 2. Now, I have to split that up, so if I do 4 to the 1 over 2, that's 2, because that's just the square root of 4. So 2 cubed is 8. 8 minus 8, that's 0. In the bottom, I get 4 minus 4, that's 0. So this is indeterminate, so I got to do something. Okay? So, again, what I can do is the following. Let's see. Got it. Okay, so limit as x approaches 4. Now notice how I wrote the original, this monstrosity, right? X minus 8 turned out to be this. I'm going to kind of pull a trick like that, right? Watch this. So I can rewrite this. Root x cubed. Okay, that's this guy, right? Root x cubed is that. Okay, check it. This is minus 2 cubed. That's a difference of cubes. Okay, here I've got root x squared. Okay, that's just x minus 2 squared. So I've got a difference of cubes and a difference of squares. Difference of squares again is this. Okay, so I have to identify what a and b are. In both cases, a is root x. In both cases, b is 2. So I just have to use my formulas, and then I can get a canceling, right? A cancellation. So the cancellation will be of root x minus 2, because I get root x minus 2 in both the top and the bottom. And guess what? That's the problem. That's the issue with the direct substitution that's not letting me do it. So I end up getting, let's see, so it's the square of root x, right, in the top. So that's x. Again, please check this. Plus 2 root x, okay, plus 4. In the bottom, I end up getting root of x plus 2. That's the only factor that's missing, a plus b, right? So this is what the one that's canceling, so I end up getting limit as x approaches 4, okay, of x plus 2 root x plus 4 all over root of x plus 2, okay? Now I can plug in 4, okay? So let's do that. There's no problem now at this point. 4 plus 2, root of 4, which is 2 plus 4. 4 plus 4 plus 4. Sounds familiar. Root of 4 is 2 in the bottom, so 2 plus 2. So I end up getting 12 over 4 again, which is 3, right? So the answer is 3. All right, so last one for the video. I don't even know how many minutes I've gone into, right? This is quite a bit, because I ended up doing, let's see, what is it, like 6 questions per, 6 questions for 5. I think it was 6 questions for 4. That is 12 questions, and now 3 questions. So yeah, it's quite a bit. 15 questions. So yeah. So let's see. Next is part C of number 6. So limit as x approaches 1, and we've got root of x minus 1 all over the cubed root of x minus 1. Okay. Now, in this case, I obviously can't plug in 1, right? I can't just go ahead and do direct substitution because I get 0 on the top, I get 0 on the bottom. Okay, the cube root of 1 is 1. So I can't do that. So I got to figure out something. Key is don't panic, right? Let's see. And this one isn't looking too obvious either. I know I probably got to pull out something that has a factor of 1. Or, sorry, a 0 of, a factor that that's 0 is 1. Why don't I do let's see. I can rewrite. Why don't I try that? I can rewrite the top. I can do root x, and then do cubed 1 over 3. Okay. Okay. You might be thinking, man, this guy's losing it. I might be a little bit. What I can do is I can rearrange. I can put the 1/3 out instead of the square. I could put the cubed root out instead of the square root. But I don't think that's going to help me much. Okay, what if I did the square root? So what if I did x2 over 3, okay, minus 1, okay. Is that better? Not really. That's not good. I don't think I can do that. I guess it's not coming to me right now. I mean, I could try conjugation, but I don't think that would help much because I can't pull out anything to cancel out of the bottom, right? So but if I do that, okay, follow me. So the conjugate of that, of the bottom, I can trying to look at this as a difference of squares, but I don't think that's going to help. It's not going to help much. Yeah. Nope. I think what I'll do is I'll call it a night on this problem, and I think I'll come back to it. And if I figure something out, I'll post it in the next video. I think that would be the smartest move. As of right now, I can't really figure my head around this one, but hopefully I'll be able to get it soon. So I'm stumped, but hopefully I'll get it in the next video as we move on. So in the next part, right, what we're gonna do is we're gonna talk about continuity, right, and discontinuity, and so like removable infinite discontinuities, stuff like that. We're gonna talk about the definition, the first principles for the derivative, right? Because this is a calculus course. So yeah, so we'll do that, and yes, thank you for watching, and I guess I'll see you next time. Yep, I got stumped. Thanks, guys, and please make sure you do subscribe to us. We love what we do, and so subscribe to us. Follow us on Instagram at Lehigh Tutoring. And I'll post some stuff in the description box, right? Please look at it. The PDF file will be there. The Instagram handle, all that stuff. Please subscribe, and thank you so much, and have a good one. Bye.